All right, guys, this is the video lesson for Chapter 12, Section 3 on inscribed angles. Let me give you a difference between what we've learned previously and what this one is about. Actually, hold on just a second. Let me recenter that. Okay, so what we've been doing primarily is central angles. And if that's the center, circle C, we'll just call that the center, then the angle measurement of the central angle is equal to the measurement of the arc. But now we're going to do inscribed angles. Let me show you what that is. Okay, an inscribed angle looks like this. You'll notice that the vertex is also on the circle. Okay, so if this is B, and this is A, and this is C, this is what Theorem 1211 states. The measure of angle B is equal to half the measure of arc AC. And remember, we do an arc with a little thing over there. So if, for example, the arc AC was 60 degrees, then we would say that the measure of angle B is 30 degrees. Okay? Now, every single time this will apply, we're not going to worry about proving it. And I'll let you look at the example of problem 1 in your books. It's a little bit much for me to try to copy it onto here, but go through the steps that they have there, and it give you a good example of what type of homework you might have on Math Excel. All right, now you also have some corollaries to this Theorem 1211. Number 1, if you have two inscribed angles that intercept the same arc. So what if I did another one here? Whoops, got it on the wrong part. What if I did another angle here and here? Does that angle D also open up to arc AC? Well, it should make sense then that both the angles and the arcs are congruent. Okay? Because the arc is obviously the same arc, so the angles must be congruent. Now, also related to that, this corollary. If I draw a diameter across, okay, anytime I get an inscribed angle that opens up to a semicircle, since that semicircle or that diameter is 180 degrees of the circle, we know every single time that that inscribed angle has to be a right angle. Okay, so you can almost see some of the math problems that will come up because of that. So anytime you've got an angle inscribed in a semicircle, that angle will be a right triangle or a right angle. And then finally, the third corollary says this: the opposite angles of a quadrilateral inscribed in a circle are supplementary. Here's the idea. Let me draw a circle. And then let's get a quadrilateral like this. Does not have to be a rectangle or anything else. But because of the way this works, A, when it opens up, always opens up to this arc formed by B to D. And B, when it opens up, is formed by the arc from C to A and such and so on and so on. Since all of these arcs are twice the measures of the angles, and we've got 360 degrees, we now can say that the opposite angles have to be supplementary. Well, I can't really draw it as congruent, but just supplementary. In other words, D and B, the measure of angle D plus the measure of angle B equals 180. And you would say the same thing for A and C. All right, so again, I'm now going to turn you towards problem number 2. in your books. I want you to look at your online books and go through problem number 2 as an example of how those corollaries work. It's got in the book the answer and how you get about to it. I think that should be enough information with the general knowledge. And you're starting to see, guys, some of the things that you need to put into your notes so that you can easily access for this next test next Friday. Finish erasing the rest of that. All right. Finally, we get to another theorem, Theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So I've got to show you the visual first. Here's my circle. Here's a tangent line. Okay, that tangent line is going to also hit, let me think how I can do it. Let's go from there, from that point of tangency, straight down. And then the book kind of makes it easier to visualize by not showing the entire tangent line. Okay, so we've got a chord and we've got our tangent. Our tangent here is formed at point C. Our chord is BC, and then D is there, and our center is there. All right, so the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay, so this is the angle right here, and it's formed by half the measure of the arc that's been intercepted there. So the arc is from B to C, and it would be half the measure, or in this case, BDC, to show the entire amount. So the measure of angle C is equal to half the measure of arc CDB. All right, so that's another way to kind of find out information about arcs and measurements. That should give you enough basic information. Again, I refer you to problem number 3. I want you to look through problem 3 in your book right after listening to this video or this portion of the video, and look at the example they've got there as you've got some arcs and some chords and everything, and you're trying to figure out angles. Should give you some pretty good practice of that. All right, guys, good luck with that. If you need help, I've got tutoring here Thursday. It's about 12:30. I'm finishing up this video, so I'll have tutoring Thursday and Friday at 1 o'clock. Look for those links and come in for tutoring if you need help on a few of the problems. Hope y'all are all having a good week.